I work for Scott Logic. We are a technical consultancy specializing in all kinds of different cloud technologies. We work in the finance industry as well as in the public sector, and we do a huge amount of work. We've got some great JavaScript developers. I myself am a recent joiner to the JavaScript community, so I hope you'll be kind to me. But today I'm going to talk about serverless APIs with JavaScript, so focusing a little bit more on the back end rather than the front end, where I think JavaScript has really made its name and had the biggest impact on technology. So just a brief thing is what I'm going to talk about. I'm going to do a brief intro into serverless, what it means when I say I'm going to be talking about serverless technologies and that sort of thing. I myself am an AWS solutions architect, so I apologize if this feels like I'm pushing AWS on you. I'm definitely not, and there's some great options out there. And everything I talk about is applicable to IBM, to Google Cloud, to Azure, whatever it is you're using. I'm going to do a little bit on AWS API Gateway and AWS Lambda, just so that we know we're talking about the same thing. Some best practices, and a small library that I've put together on GitHub called Lambda, which will help you get started and get going with some of those best practices that I'm talking about to create some great serverless APIs. Cool. So, what is serverless? What does it mean when I use this buzzword? Well, the first thing is that there is definitely a server, so it is a bit of an oxymoron. When I'm talking about serverless technologies, what I'm really talking about is pushing the responsibility of some of what we do in the back end in terms of maintaining our servers, maintaining the operating systems on which our servers are running, the hardware, the load balancing and that sort of thing, giving some of that responsibility back to the cloud providers. If they're going to provide the hardware, why not let them provide the operating system as well? I mean, if you're using .NET Core or you're using Java, the operating system is kind of secondary anyway, and so it lets developers really focus on what they know and what they do best, and that's delivering business value and doing cool stuff, really. So yeah, here's a few of the things. So if you're talking about serverless technologies, quite often you're talking about giving away things like responsibilities like load balancing, configuring high availability and other such things, and giving that responsibility over to your cloud provider. So what can you do? What serverless technologies are available if you're not familiar? And the answer on AWS is absolutely loads. This is a tiny fraction of the names of some of the serverless technologies that AWS offer. They were largely chosen because they had different colored logos. But do take them down, so there's some great technologies up there. Aurora is blisteringly fast, and that is a database up in the cloud. It's a database where you don't have to deal with high availability of your database. You're not dealing with storage. You basically just say, I want to use Postgres as my sort of query language, and then you get this database that just scales with your application. And one of the brilliant things about serverless technologies, pretty much everything that you see on here, particularly like Lambdas, which we're going to get into in a bit, is that you really pay for what you use. So if your Lambda is getting called once a month, you only pay for that one invocation. It's not like your kind of old school cloud model where you configure an EC2 instance and you are paying to have that instance running in your server ready to receive those requests. If you're not using that API or you're not using that resource, you don't pay for it, which is an easy thing to sell to your business friends. And as a consultant, it's really great to sell to businesses as well. So, when we're talking about serverless APIs, as was the title of my talk, key component inside AWS is known as the API Gateway. That is either a RESTful or WebSockets API that you can configure. You can configure it using Swagger. I'm not going to go into that as much today, but there are some great tooling that my friend Matt over there in the mustard yellow shirt has written, and you can, by adding Swagger annotations to your JavaScript code, you can effectively have your API gateway and your API version controlled and move forwards with your Lambda. You can have things like your cause configuration and validation all done inside API gateway, configured in Swagger right next to the business logic of your functions. It makes for hugely maintainable code, which is really, really helpful when you're talking about serverless applications, as you'll see in a bit. The next thing I'm going to talk about this quite a lot, are Lambdas. Lambdas, if you're not familiar, is a function as a service, AWS service that is provided to you. They are small independent units of code which can be executed as a result of the result of an event. So that could be someone uploading a picture to an S3 bucket that you've configured, a database, someone adding something or doing something in a database in your back end, or it could be someone hitting your API gateway and you put that function to provide whatever it is that your API does. So as you can kind of see where I'm going, it's microservices everywhere, and they really are super tiny. As an example here, this was taken straight off the AWS website, and I promise we will move on from them in a minute. You've got here the idea of just a photo's taken, users using an app, uploads it into an S3 bucket, and you've got an AWS Lambda there that would then resize that image so that it's optimized for the different devices on which the Seattle Times can be viewed and downloaded. That's just one kind of really simple use case that you can see here. The Lambda would be triggered from the upload of the picture. Another example would be if you're running a social network and someone sends out a status update, maybe they take a picture of their food or whatever it is people do on social media. You have a Lambda that is triggered by that, and that would then send an SMS notification, another serverless service by AWS, and that can then send a notification to all of the user's friends to say, hey, check out this salad that I just got from this Kakuru robot. It's great. Yeah, cool. So some best practices when writing code for Lambda. So on the left here, we have a few that I'm gonna talk about. So one of the biggest things when writing Lambdas is to really separate your business logic, because one of the key things that Lambdas are trying to do is create these tiny little bits of business functionality that you drop into your application in different places. Like I said, whether it's someone's uploaded a picture to a data store, someone's done something in a database, whatever it is. And so you just want to really distill that down. And that has performance benefits as well, which is super important. Something I haven't mentioned is that Lambdas are charged based on every 100 milliseconds of processing time that you use. So if you can simplify your logic and you can take it down from 250 milliseconds to 190, that actually has an impact on your bottom line. And it's way easier to sell that sort of thing to the product owners of the world and these other people. Next thing I'm going to talk about is around execution context reuse. And again, this is a performance optimization where Lambdas under the hood are effectively tiny little containers that get spun up. And there's another slide where I'm going to go a little bit deeper into this. But what you want to do is you have a cold start and a warm start. And that is when you are spinning up a new container, that's going to take you some time. And you're also going to do some initialization ready for your business logic. If we can make sure that we are reusing as much of that container as possible, then when that second invocation of that Lambda comes and you've got a warm container that doesn't need to be respun up, you're saving money, and who doesn't like money? I don't know where else to take that. And the other thing that I really advise you do is you minimize your package size. And this is where JavaScript has a huge amount of headway over some of your more traditional languages. If you're talking about putting class files and jars up in your AWS Lambda, and you can, and if that's the language you like, great. But when we can with JavaScript, you can create these really, really little tiny text files, as I'm sure you all know, where you minify your code and you uglify your code and all that sort of thing, and you get it down to a few, kilobytes that you have in your Lambda. That's going to really improve your cold start time because you have way less to load and way less to get running. And that's where JavaScript is going to start invading people's back ends. And the likes of Java and C# are already going to need to be worried about that. In terms of the points on the right, which hopefully you're going to read, there's some great articles online. I mean, Lambda was one of the first kind of serverless services that AWS provides. There's loads of information, including a great white paper there if you want to get into the details of this. So just what I was talking about with execution context and execution context reuse. This is kind of the life cycle of an AWS Lambda. So what you have is this thing where you're going to need to download your code and any dependencies of your code. And that's going to be the zip file that you upload. That actually gets stored in an S3 bucket somewhere. And then AWS have to start up these tiny containers. It's not as expensive as it might sound. They've done a lot of work into that. Then you've got to initialize and start your code. And that initialization step could be opening up a connection to a database. It could be opening a connection to an S3 bucket, whatever it is. That's then the next step. And then finally, we get onto the execution of your business logic. And this is where, for now, I'm going to focus for the purpose of this talk, because we don't have too long to talk about kind of low-level optimizations of cold starts. But like I said, that AWS white paper in the previous slide has some really awesome stuff, and there's some great stuff on the AWS labs if you want to start designing your own runtimes and things like that to get in there. So I'm going to talk about my library. Like I said, it's called Lambda. You can find me on GitHub, and I have this library there. So there's my GitHub tag if you feel like following me or whatever. I'm looking for more friends. So a little bit of shameless self-promotion, but this library was actually inspired by another library called MIDI.js. I just have a bit of an obsession with functional programming, and so I wanted to try and create a purer, more immutable version of MIDI.js, and I've just found that I've added a few extra features that they didn't have, and I'm really, really happy with it, so here I am to tell you all about it. So let's finally take a look at some code. Why not? So this is what I'm going to talk about, the evolution of kind of a little pet project that I was working on while I wasn't consulting with Scott Logic. And this is kind of where you might start if you were writing an AWS Lambda that was behind, say, an API gateway. So if you're writing an API, you're going to need to do something really basic, like, say you've got a JSON body in your request. You're going to want to deserialize the JSON from that body, check that it's valid JSON. You might have some validation in there. You're going to want to deal with any errors in that JSON and that sort of thing. And that's going to add a lot of boilerplate to your Lambda functions, and it's not talking about your core logic. So Lambda leverages this idea of a middleware pattern, where instead I've commented out all of that boilerplate, and obviously we can delete commented code, because who likes that? And instead we just say, right, I've got my async function, I'm using the event body, I'm going to do some work, I've just got to wait for the function bar in there, but that would be your real business logic, of course, and return the result. And I want my JSON body parser, and that's going to deal with any kind of deserializing of your JSON. You can write middlewares to do your validation as well. API Gateway has some integrations for that, but if you're doing it in the Lambda because you've got a cool JavaScript library or whatever you want to make use of, Lambda is totally extensible to write your own middlewares and do all of that for you. And I have this HTTP error handler, which is also part of the life cycle of a Lambda, and it allows you to throw these errors. It will normalize your response into something that API Gateway can understand, and it will allow you to create a nice, consistent API. Cool. So like I said, talking about the life of a Lambda. My idea for Lambda was very much that I wanted to use function composition. So what I have are kind of like 4 functions that I composed together to create your final Lambda. So we start off with initialization, And this is where you run that initialization stuff. So any kind of reusable resources that you want to create for your Lambda, you put them in that initialization step, which I will show you in the next slide, and they will get reused on any warm start. So you don't need to worry about that kind of thing. You don't need to be thinking, how can I optimize this? If it can be reused, you pop it in there and it will be reused for you, and you don't have to pay that extra cost. Then we have these before middlewares or pre-execution middlewares, whichever way you like. And they are going to do things like validate the request or the event that's triggering your Lambda. They're going to normalize that request. Maybe you want to change the case of your headers, or I don't know what you want to do. Whatever it is you want to do before the execution of your business logic, it's handled in there. Then, of course, we have your business logic, and then your post-execution middlewares. And in there, you've kind of got the two paths, so you can have some error handling if you are, I don't know, if something's gone wrong, or you want to respond to say this is bad. And you can also have normalization of your response. And in there, I do a little bit of work to hide some of the nuances of the AWS API, Lambda API. And so here, what we have is a pretty simple Lambda, which is going to take some JSON in the body, and it's going to pop it in an S3 bucket for me. And so what I've done is in my initialization step down there, I've initialized my connection to S3. And like I said, that's going to get reused, that's going to get cached. And so what that means is the more people upload onto this app, the faster my performance is going to be. And the faster my performance is, the less this is going to cost me to do. Which is, you know, again, it's all money, isn't it? So here's a kind of architecture for a small application that I was working on. I'm not going to go too deep into this because I've got to watch the clock. But what we have is a couple of serverless front-end websites sitting inside an S3 bucket. Then we have a Lambda very similar to the one that I just showed you, whereby this is actually for a recruitment app. So I've got applicants that are chatting to TRG. They upload their details through the front end. That's going to talk to a Lambda, which allows them to put all their information safely in an S3 bucket, and some other data that goes into a DynamoDB database. And we've got some other stuff to let TLG and the recruitment managers know how much you all want to work with them. I should mention Scott Logic are also hiring. Cool. As a best practice, I quite like in this application, I pre-configured all of my middlewares. So I just sort of wrapped it up and I said, well, I'm going to have this header normalizer so that my headers all look quite good. Oh, sorry, this dangling thing is a little distracting. I've got my JSON body parser. I've also created this options request interceptor to handle the cause, because like I said, Lambda's totally extensible. If you've got some bit of functionality you want to add as your boilerplate or whatever, perhaps an integration or something like that, you can write, and there is great documentation, you can write your own little piece of middleware, and that will be incorporated into the workflow. And then this is what the Lambda for the application we saw earlier would end up like. It's very similar to the one I showed you before, whereby in my initialization step, I'm going to set up my connection to S3, and that's going to get reused and be saving me money. And then I've got a higher order function where I'm generating signed URLs to allow the user to upload their CV securely to the S3 bucket, so that can be hidden away and there isn't an API exposing any of that data. The body up there, because I set up that JSON body parser, that's deserialized, that's just a normal JSON object. It's been validated and all of that sort of thing. You don't have to let it confuse or get involved with any of your business logic. So what we can see here just clearly is I'm just going to reduce over the list of files or CVs that were going to be uploaded and give back the URLs. So here's some things I've not talked about, which I would have loved to have chatted about, and there's loads of Scott Logic guys over there that would love to tell you all about them, I'm sure, as well as some of the other things you can be doing. So I mentioned earlier that you can use Swagger annotations on your Lambdas, and you can use those annotations both to test your Lambdas, because Lambda introduces some really great test tools, as well as to configure your API gateway, which gives you version controlling and links that all together. Blue-green deployments, and just general kind of infrastructure as code. So the integrations with this and say Terraform and that sort of thing. There's some really great tooling out there, which perhaps you can ask questions about if you have any. Thank you.